Welcome everyone to our webcast. We have Scott Hendren with us today talking about using Excel analysis features in Creo. So Scott, thank you for joining us today. I'll pass things over to you.
Thank you, Corrine. So welcome everyone. What I'm going to present today is one of the chapters from our Creo 4 behavioral modeling course using Excel analysis features. So what I'm going to look at is how to create Excel analysis features, what they're all about, learn where Creo where those Excel analysis features and Excel files are stored, and review a couple of configuration options that go with this. Sort of fair warning to everyone, I had a bit of a phone issue earlier, so I'm trying to drive this as well as hold a phone to my ear, so hopefully I don't drop it and have it bang in your ears. I will do my best to hold on here. So first, sort of creating analysis features, Excel analysis features and what they're all about. So Excel analysis features, if you have the behavioral modeling license, allows you to take information from your Creo Parametric model, dimensions, parameters, push those into an Excel spreadsheet, do some calculations within that Excel spreadsheet, and then push information based on those calculations back into your Creo Parametric models. So what we will actually look at today is we have a heat exchanger, and we're going to do some calculations for that heat exchanger based on some graphs that we've set up for some standard efficiencies, and find out the heat transfer that's associated with that heat exchanger. So this is one of the exercises that's found within our course. So to create an Excel analysis feature, you open up an analysis in the analysis dialog box. You select the Excel analysis feature, and then the system opens up the Excel analysis dialog box. And you have a couple of options here. You can load an existing Excel spreadsheet, which is what we'll do today, or certainly you can create a new Excel spreadsheet from scratch. Once that spreadsheet's open, you then select dimensions or parameters that are found in your model, whatever's appropriate for your analysis, and you select the cells within the Excel spreadsheet where those values will be placed. So those will go in the Creo Parametric to Excel fields. Once you've added those in, and again you have multiple calculations that occur within your spreadsheet, you then select the cells that will be pushed back to Creo Parametric, and you do that in the Output Cells area. Click Compute, and the system computes values based off of those fields within your Excel spreadsheet. So there are actually two ways that you can create an Excel analysis. You can just flat out create an Excel analysis, but when you do that, it doesn't create any parameters. So if you create an analysis feature and select Excel analysis as your type, then that actually provides you the ability to create those parameters that you want to use. So once you've set up everything within your spreadsheet, selected the output fields, within the analysis feature, you have your result parameters that you can create. By default, the system names those parameters based off of the cells within Excel where they're found. So in this case, the first parameter was in row 24, column 4. The second parameter was in row 26, column 4. But of course, you can name those parameters to be whatever's most appropriate for your situation. When you create an Excel analysis, the system stores the absolute path to where the Excel file was stored. So when you go and open your part file and you want to run or regenerate your model, the system looks for that path to find the Excel file. There are several locations where it will look if it doesn't find it, so it'll look for the path, it'll look in the working directory, or if you've specified in Config.pro the Excel Analysis directory, it will look there for that Excel file. If something happens and that Excel file is missing and Creo can't find it, your model won't fail, but it will simply regenerate with its last known values. If you then find that Excel file or create a new Excel file, you have to set up your analysis again. Another config option, and this isn't specific necessarily to Excel analyses, but within behavioral modeling, if you want to graph any results, there is another configuration option, bm_graph_tool, and that you can set to the default, which is just a regular Creo Parametric graph window, or you can embed Excel within Creo or link to an external Excel file, and it'll display your graphs based on those settings. So what I'd like to do then, now that we've kind of looked at what these Excel analyses are, is actually take you through the process of creating one. So what we'll do is we'll look at this heat exchanger, and we're going to run an analysis on that heat exchanger. So before we get started, we'll take a look at kind of how this model is set up, a couple of things that we put in place for it, and we'll take a look at the spreadsheet that's going to drive the geometry as well. So within this model, we have several graphs that are set up, and these graphs are just based off of standard efficiency graphs, and they relate to the geometry of the model. So basically what will happen is Creo Parametric will, based off of the Excel spreadsheet, we'll look at that in a second, it will find a value, it will then go to these graphs, and it will select the appropriate efficiency off of that graph based on our calculations. So in the spreadsheet, we have the variables that will come from Creo. So we'll use the thickness of the fins, the radius of the fin, the radius of the inside cylinder, the height, and the number of fins. And all of that information will come from the Creo Parametric model. There's some assumptions, of course, steady state conditions, negligible radiation, et cetera. And some variables that are in the spreadsheet but that don't come from Creo. So this is based off of aluminum being the material. So we have a couple of variables that are here. Then we have some heat transfer calculations, some equations. And then some values that we will pass back to Creo Parametric so that it can then go to those graphs, select the appropriate efficiency, and we'll push that value back to the spreadsheet. So there's a lot of kind of sort of back and forth here between the model geometry and the spreadsheet. And then finally, based on that efficiency and some additional calculations, we'll come up with the heat transfer for the model. We have some calculations here in this relations analysis feature, and we'll just take a look at those for now. So this is where this model and these calculations will actually go to the graphs. So when we're looking for the efficiency value, it will look into the graphs, graph 1 based on one set of values. It might look at graph 2 based on another set of values, all depending on how things are calculated within that spreadsheet. To set this up, we just used a dummy value for now for the feature ID, but we will create an Excel analysis. We'll swap out this feature ID for the ID of the Excel analysis, and then it'll run through these calculations. So let's cancel out of this, and we'll get started creating the Excel analyses. I have Excel open right now. It doesn't have to be, so we can just close that up, and we'll run this from scratch here. So what we want to do ultimately is find the heat transfer that's going on in this heat exchanger. So our first step, we're going to create an analysis feature, and it'll be a relation analysis feature. I don't know how much of my screen everyone can see, so that's why I'm sort of sliding things over to the left here just to make sure everyone can see what's going on. So we'll create a relation analysis feature, and we'll call this analysis feature fins for Excel. And we'll hit enter. If you haven't used these analysis features much in the past, it's really important anytime you type something in to always hit enter. If you just continue on, it doesn't accept what you've typed in for things like the names. So we'll create a relation analysis feature. And this first one's pretty simple. We're just going to type in fins equals n. So that just sets the number of fins to a parameter that we've predefined in the model. So we can complete that relation analysis feature. So now what we'll do is we'll create our Excel analysis feature. And actually, I made one little mistake here. We want to put all the stuff before this efficiency analysis, so I'll just activate insert mode, and then we can insert everything above that efficiency relation analysis. So now we want to create our Excel analysis feature. So we click analysis, and for the name, we'll type in find efficiency. And we want to make that an Excel analysis feature. So that opens the Excel analysis dialog box. And here, as I mentioned earlier, we can load a file or we can create a new one. So we have one already set up. So we'll click Load File. And it's Heat Transfer 1. If you're using sort of newer Excel and maybe it creates an XLSX file, just go to the type area down here, and that's an option for you to select. So once you select the Excel file, it opens up, and we have the values that currently reside in the Excel file. So what we want to do, as I mentioned earlier, is input values, push values from the Creo model into the Excel spreadsheet. So we can add dimensions. And we'll just spin the model a little bit here. We want to add dimensions from the cylinder as well as from the fins. And we'll just switch those symbols to their dimensions to their symbolic form. So the first dimension we want to add is the thickness. So we can select that value and select in the Excel spreadsheet where we want that value to be pushed. You notice currently it's 6. That's the value that's in the spreadsheet. When I hit Done Select, that now updates the Excel spreadsheet with the value from the model. We can continue to add these values in. So this R1, we can enter that value here. R2, we can enter that value here. The height, add that value here. And that's all the dimensions that we want to add, so we can middle click and that stops the selection. And now what we want to do is add a parameter. So we click Add Parameter, and we want to select that fin parameter that we set up in the relation analysis. So from the select parameter dialog box, we just click that, click OK, and then select where we want to push that to in the spreadsheet. So that adds that parameter in to the spreadsheet. So now we need to, those are all the values that we want to put into the spreadsheet. Again, we're going to make some calculations based on those values, and then we want to return to Creo Parametric these two values here. So we can select output cells and select these two cells using Control to select them both. Hit Done Select, and those are then added to the Export to Creo Parametric field. So again, when this regenerates, it'll go to the Excel spreadsheet, do the calculations, and then push these values back to Creo. So we click Compute, and that computes values for those two cells. So that finishes the Excel analysis, so we'll close that up. And what we want to do in the analysis feature is actually use those two values as parameters in the model. So again, the first value comes from row 54, column 2. The second value comes from row 57, column 2. So we'll make those more meaningful, and we'll rename those parameters. The first one we'll call x-axis. And what we will do is use this parameter value to go to our graph and find the location on the x-axis of the graph. Again, remember to hit Enter every time you type something in. And this one we'll call line, and this will be used for the y-axis. So those two parameters now will be created, so we can finish that. And we'll now resume that efficiency analysis feature that we suppressed earlier. So we'll edit its definition. And again, where we had this just as a dummy variable initially because we didn't know the feature ID of this find efficiency analysis that we were doing, we just left those in as 1666. So what we'll do is replace that now with find underscore efficiency. So within this relation, we can find and replace that value. And we will replace the 1666 with find efficiency, replace all of them, and verify the relations. So now these relations will calculate, after the find efficiency Excel analysis is done, it'll come in here to this relation analysis, and it'll run it. And it'll take the values that we've pushed and look at these graphs to find the value for the efficiency of this heat exchanger. So we complete that, and we're set from this point forward. So now what we want to do is to actually find the heat transfer that's happening within this model. So we'll create one more Excel analysis feature. And we'll call this one total heat transfer. Again, always hit Enter, Excel analysis, next. We'll load that same spreadsheet. And we'll have to, because this is a different Excel analysis, we will have to select the dimensions and parameters again. So we'll add the thickness here. Radius of the cylinder here. Radius of the fins here. And the height here. One thing about using Creo with Excel in this way is there is a lot of sort of flipping back and forth between the windows. Most of it occurs automatically. Sometimes the Excel spreadsheet will get sort of stuck, if you will, behind the Creo window. So that's why I have my window set up so that I can always access the header of the spreadsheet if I have to, the area up here, so I can bring it forward. So those are all the dimensions, and then we'll add that parameter here. So we've added all the dimensions, we've added we've added that parameter. And so now what we want to do is to add the efficiency parameter and push that into, into the Excel spreadsheet. So again, we'll add parameter, and it's calculated from the efficiency relation analysis feature that we just looked at, and we're looking for NF as the parameter. And we will place that one in this cell here. So that's the calculated fin efficiency. So now that we have all of this information together, now we can do the calculation for the heat transfer. So we need the output cell. So this is the cell that will be pushed back to Creo Parametric. And that cell is found here. So 1108 watts. So we can close this, and we'll add that parameter. We call that parameter heat underscore W. And we can complete the Excel analysis. So just so we can see that parameter easily, we'll add it to the model tree. Okay, so we can see that heat transfer value added here in the model tree. So let's make some changes to the model. So let's say we want to see what happens when we set the thickness of the fins to 6 instead of 3. So we regenerate that. It runs through all of the calculations that were in the spreadsheet and comes back with a new efficiency or a new heat transfer of 1160 watts. Maybe we want to change the number of fins to 5 instead of 6. So we can't edit the number. This is a pattern, obviously, of fins. We can't edit that directly because it's driven by a relation, so we'll just edit the parameter. And we'll make that 5 instead of 10. And regenerate. Goes through all the calculations, and we see now that the heat transfer is only 698 watts. So if you make one final change, maybe we change this thickness to 2. And maybe we set this parameter for the number of fins to be something higher, say 25. And we regenerate. It goes through all of those calculations again. collapse the pattern here. And we have 2400, 2356 as our heat transfer. So using the Excel analysis, it's kind of a nice way to take some information that you already have. Maybe it's already in a spreadsheet. You might have, you know, some legacy information, calculations that were done over time in these spreadsheets, and be able to use sort of the power of Excel to go to it, push some data to it, do some calculations, and push that data back to Creo Parametric to get some results that you require. So that's what I wanted to show for today.